Hey, Bill Nye the Science Guy here for Google Earth's Mars 3D. In the 1900s, our ability to explore Mars via telescope from the Earth had reached its limits. And combined with our growing spacefaring capabilities, Mars became an excellent candidate for robotic exploration. Our first visits to Mars with spacecraft were only flyby visits by the Mariner 4, 6, and 7 spacecraft. Now, these quick passes, while spectacular, only allowed for a few limited in scope, low-resolution images to be taken, which really only showed plains and craters, kind of a moon-like view. If we did the same thing with the Earth, we might have only gotten pictures of the ocean's surface or clouds and not even known there was any dry land. It wasn't until Mariner 9 went into Mars orbit in 1979 and started systematically mapping the planet that we really got a good sampling of the wide variety of Martian geology. Along with our orbital spacecraft, we also sent robotic explorers to the surface with mixed success. The Soviets were the first to attempt to land on the Red Planet with their spacecraft called Mars 2 and Mars 3, which arrived during the height of the 1971 dust storm. Mars 2 was lost, but Mars 3 might have made it safely to the surface. No intelligible signal was ever received. Mars 6 returned data as it descended through the atmosphere, but the signal was lost when the spacecraft was expected to land, indicating that there was probably a crash. The first successful landing was NASA's Viking Lander 1 in 1976. It touched down in Krisa Planitia, a vast flat desert whose initial soil analyses indicated that the soils were primarily volcanic, but there was evidence of salt and other minerals, indicating that water perhaps had once flowed across these plains. The Viking 1 and Viking 2 landers had an array of scientific instruments with which to sample their new home, but the most talked about was the biology experiments. The Viking landers carried a small wet chemistry lab and an arm to deliver soil samples into each one. The experiments determined that scoop-accessible Martian soil was sterile, most likely due to ultraviolet radiation, but another part of the experiment detected some sort of chemical activity, which, while exciting, was just a chemical reaction that most researchers think had nothing to do with life or any living thing. 20 years later, NASA sent the Pathfinder lander to where Ares Vallis empties into Krisa Planitia. In addition to the medium-sized lander and its instruments, Pathfinder brought with it a kid's wagon-sized rover we called Sojourner, which puttered around the lander, examining rocks with its instruments and learning things about what must have been the Ares Valley's flood. In 2003, NASA launched the Mars Exploration Rovers, the MERs, which later came to be called Spirit and Opportunity. They landed on Mars in January of 2004. Spirit was sent to the plains of Gusev Crater. Its first stop was the nearby Bonneville Crater, but after that it made tracks for the Columbia Hills off in the distance. The Columbia Hills are named after the Columbia Space Shuttle, which crashed in 2003. Almost 6 months from the time of its landing, Spirit got to the foothills and started switchbacking its way to the top of Husband Hill. Now, Husband was one of the astronauts on the Columbia Shuttle. It took Spirit a whole year to climb to the summit, but once there it had a marvelous view, and it got a good look at the feature named Home Plate and started heading toward it. Spirit spent a lot of time here exploring the area and characterizing the minerals and stratigraphy exposed on Home Plate. The Spirit and Opportunity rovers are identical twins, or nearly identical, and they're equipped with 9 cameras. They have 2 HAZCAMs, or hazard cameras, looking forward, 2 HAZCAMs looking back, 2 NAVCAMs, navigation cameras. They're mounted up on the mast, which is as tall as a 10-year-old's eye. What I mean is as high as a 10-year-old's eye. Then up there also are the 2 PanCams, panoramic cameras. They're for the panoramic color and science on the mast. And there's 1 microscopic imager out on the rover's arm. Now, the microscopic imager is like the hand lens that a geologist might carry. That arm also has some spectrometers for measuring different aspects of the rocks, and the RAT, the rock abrasion tool for grinding and brushing rocks off so you can get through the rind of weathering, provide a clean surface for the instruments and the geologists here on Earth to have a look at. On the rover's back, nestled amongst the solar panels, are various antennae, and on the aft solar panel, there's a curious little thing called the Mars dial. The other Mars exploration rover, Opportunity, landed in Meridiani Planum, almost in the middle of a small crater, an interplanetary hole-in-one. Its first stop was the medium-sized Endurance crater, which it drove into and examined fine layers exposed there. It then started driving south. It passed its own heat shield from its own descent module and even got stuck in some deep sand. It took quite a while before it eventually reached Victoria Crater with its magnificent exposures of sandstone. Opportunity then circumnavigated a good distance around the North Rim before coming back around to the west, driving down into Duck Bay, where it examined the layers on the side of Cape Verde. After that, it drove around to the southwest of the crater and started booking south. Opportunity's next big destination is the much larger Endeavour crater. It's 14 kilometers away, 8 miles or so. In Opportunity's 5 Earth years of operation, it has only gone about 6 kilometers, 4 miles from where it landed. So it may take some time to make it to Endeavour crater. The most recent spacecraft to land on Mars, the Phoenix lander, did so far, far to the north of the other landings. The HiRISE instrument, a high-resolution camera aboard the Mars Reconnaissance Orbiter, captured this image as Phoenix was descending on its parachute. Although it looks like Phoenix landed inside the Heimdall crater, the orbiter was actually very far away and took the image at an oblique angle, creating this optical illusion. In this image, Phoenix is about 20 kilometers in front of the crater. The cutout at the left shows a blown-up version of Phoenix hanging from its parachute during its descent. Phoenix actually landed on the plains well outside of the Heimdall crater. Phoenix landed so far north at a position similar to the high Arctic on the Earth that the team knew the spacecraft wouldn't last very long. It could only operate until the Martian autumn or fall, because the sun would dip down low on the horizon. The solar panels would not be able to recharge the batteries, and then it would be coated with carbon dioxide frost, a blanket of dry ice, maybe a meter or even more thick on top of the spacecraft. In its short but productive life, it accomplished a great deal. It dug trenches, probed permafrost layers. It's the first spacecraft to touch frozen water on the surface of Mars. Phoenix made many other measurements that scientists are going to be working on for a long time to completely understand.